Hello, I'm Landon Schlungen, and now is the time that we go and we're doing the demographic data analyzer. So just click on this. If you haven't opened it before, you can access it just by clicking this link. I opened it before and I don't want another one in my REPL, so I'm just going to go to it by opening up REPL.it and then going to my REPLs and doing the boilerplate demographic data analyzer. And here it is open. And the README shows us what we have to do. We have to analyze demographic data using pandas that was extracted from the 1994 census database. And this data has age, work class, a bunch of different categories. The table looks a little weird, but yeah, we have to answer these questions. What is the percentage of people who have a bachelor's degree? So let's try to do this. The file that we have to change is this demographic data analyzer.py. We import pandas right away, and the first thing we have to do is we have to read that data from the file. So this isn't too difficult. All we have to do is pd.read_csv, and that will read the CSV adult.data.csv, which is this one, which is a CSV file, comma separated value file of all of our data. So right here we have a age 39, bachelor's degree, never married, not in family, white male, who has a salary of under 50K and is from the US. So yeah, and there's just a ton of these. All right, so that's our data frame. Our data frame is like a bunch of series pasted together to make a data frame. And the way we find race count, I did it really weird before, but then I found the FreeCodeCamp forum and saw a different way that someone did it, and it was way better. And this is the way that they did it. They did DF, so data frame, and then we find race out of there. So the series of race, and we just do dot value counts, like so. And then if I run this, it has to install pandas. So yeah, up here, number of each race. So this is what we're returning, race count, but this is what we're printing. So if print data, this is what we're printing. Number of each race, and then we just pass in the race count. So we have 27,816 white people, 3,124 black people, 1,039 Asian Pacific Islanders, and then 311 American Indian Eskimos, and other of 271. So yeah, the way I was doing this before, I was doing like for loops and stuff, I don't know, but yeah, this is way easier. Next thing, average age of men. To do this, we have to go into the data frame another time, just so that we can compare things. So we need the sex of the individual, where the sex equals male. And then after we do that, we find the age. So here it's basically only selecting the rows inside the data that are male. And then after it does that, we're selecting the series of age. And then we take the series of age and we just do dot mean and we round it to 1 decimal place. So that should work for that. Let's try running it. And for some reason it has to install again, which is weird. There we go, average age of men, 39.4. Pretty neat. Percentage bachelors. This one requires a couple of steps. First thing we have to do is we have to find the total number of people with bachelor's degrees. So I'm just going to do num bachelors equals length of the data frame, where the data frame of education, or the series of education, equals bachelors. And that should work for that. So that's the number of people with bachelor's degrees. And then the total number of people is the length of the data frame. And then all we have to do for the percentage is we have to round number of bachelors divided by the total number. So that'll give us a percentage. And we want to round it to 1 decimal place. And we also have to multiply by 100 so that it's actual percentage instead of just a decimal. So let's see what this gives us. Percentage with bachelor's degree, 16.4%. It's kind of cool. So not very high, I guess. Next up, we have to find what percentage of people with advanced education make more than 50,000. And then what percentage of people without advanced education make more than 50,000. So this is a cool way to do this. We go into the data frame and we find the series of education. So we go data frame education and we do dot is in, and then we pass in bachelor's, master's, and doctorate into here. So this is finding all the people that have education of bachelor's, master's, or doctorate. And that's what it's giving us. Lower education one is basically the same thing, except there's a not in front of it. And the not symbol for pandas is a tilde right in front. So that's selecting everyone that doesn't have bachelor's, master's, or doctorate. Now we have to use this to to find this percentage with salary over 50K. And this will take a couple steps because I don't want the line to be too long. So the first step is non-percentage rich, or non-percentage higher. And this is going to equal this higher education data frame. So we're actually using a different data frame than DF. So data frame is everything. The higher education one is a different data frame that only contains the people with bachelor's, master's, and doctorates. So we find those people and we find their salary and we return them if it's greater than 50K, and then we find the length of them. So that's how many people make more than 50K and have a high education. So to find this percentage, we have to round this non-percentage variable, non-percentage of higher, divided by the length of higher education. So that's the total number. And we have to do times 100, and we have to round it to 1 decimal place. So that should give us our higher education rich. And I think I spelled this wrong or something. Okay, I don't know why that's squiggly, but let's just try it out, see what happens. All right, so percentage with higher education that earn over 50K is 46.5%. So it looks like it worked. Don't know why there's this green squiggly line under here, but whatever, I guess. Next up, we have to do lower education. So I can basically copy this, paste it under here, and just do non-percentage lower. And then instead of higher education, just do lower education. And then I can basically copy this as well and just change higher to lower. We're going to change higher to lower, and that should work for that. See what it gives us. Lower education, 17.4%. All right, cool. Next up, what is the minimum number of hours a person works per week? This one is actually pretty easy. All we have to do is use the min function. So we're going to do df. So we're going to grab the series of hours per week, like so. And then we're going to do .min, like that. And by the way, this hours per week thing, the way we're getting these is because in this adult.data.csv, that's what it is in here. So hours per week has these dashes in between, and then education is like this. So yeah, that's how we get that, just how we connect things. And then we have to find the percentage of people who work the minimum number of hours per week and have a salary of over 50K. So the number of min workers is the amount that make the minimum work hours per week. So we're going to just do length of the data frame, where we find the data frame of hours per week, where it equals the min work hours. That should work for that. Now the rich percentage is this question right here. So we're gonna do the length of the number of min workers. Okay, yeah, I actually remember why I didn't use this length thing here now. We want this to be a data frame yet, so that we can do number of min workers and then go into this data frame and get their salary, where it equals literally like greater than 50K. I know it's kind of weird, but that's how the data formats it. So the length of that, and we need to divide it by the length of the number of min workers, which is the total amount of workers who work the minimum number of hours. That's salary. And then to make this into a percentage, we have to do round and grab all of this, and we're going to do times 100, and we're going to round it to 1 decimal place. All right, let's try that out, see what it gives us. Even if there's squigglies, it still might work. All right, percentage of rich among those who work fewest hours is 10%. All right, cool. Now we need to find the highest earning country. So this one takes a couple of steps as well. This one was actually probably one of the most difficult ones for this whole thing. Actually, it is the most difficult one for this whole thing. So let's break this up. We're going to actually need to find the country count, and we're going to also have to find the country rich count. So the country count is just going to be what we did with the race thing up here. So I'm just going to copy that down, and instead of race, we're just going to do native country. So that will give us the counts of those. Country rich count, we find where their salary is greater than 50K, and then we grab their native country, and we do value counts all the same. Next up, highest earning country. We use these variables to come up with that. We do country rich count divided by the country count, so the total amount, multiplied by 100, and we do .idx max. So that finds the highest, well, it finds the country that has the highest percentage of rich people. So let's actually try getting rid of this ID max quick, and I'm just going to print highest earning country, and it should be a series, I think. Yeah. So here's our series, and then these are the percentages. So we actually don't even have to do times 100, I don't think. But yeah, what ID max does, so if I do ID x max, it grabs the index. So the first column is the index, grabs the index that has the highest value. So I believe in this case it's Iran with 41.86, and that's what we actually have to find in this next one, the highest earning country percentage, which is supposed to be this 41.86. So it might seem easy to be able to grab that, which it might be actually. I wonder if there's like a value max instead of index max, or maybe we can just do max. So if we grab this, put it here, and just do dot max, what will that give us? Let's see, try running that. So yeah, that gives us that percentage. And we actually just have to round it now. So that actually turned out cool. Just do round, and we will round it to 1 decimal place, like so. And I have an unmatched parenthesis. Oh yeah, I need to add another parenthesis here. And there we go. Highest percentage of rich people in country, 41.9%. Last thing we need is top in occupation in India. So this one's not too bad. First of all, we have to find the total amount of people in India, or just find the people of India. So we'll go people of India equals data frame, and we grab the native country series. This equals India, like so. And then we have to find the occupation counts. So we'll go people of India. We'll grab this data frame and we'll select the occupation and we'll find the value counts. So this is a way to find the most popular occupation. I just realized I might have done something wrong because it's who earned greater than 50K in India, and I don't actually check for that the way I did it, but it ends up passing all the tests anyways, which is kind of weird. So let's try running it. Yeah, it does prof speciality, and it says okay for the 10 tests. So it actually is right, but I don't actually check those who earn that greater than 50K. So I think I can just do that right in here, possibly with an and. So if we do and data frame of salary equals greater than 50K, so that should find the highest earner people of India, and it should be the same value. So let's try running that now. And it actually I get an error because I use this and thing. Oh, I think I need to put parentheses around each of these. I think that's the problem. Now let's try running it. Okay, it didn't show up. Oh, never mind, it did. And we get the same thing. Professor speciality. All right, so that's cool. And we're done, I guess. So this is a cool project for working with pandas and using it to basically query the data out of a CSV file. And yeah, pretty neat. This one is definitely a lot more difficult than the first one was, but we definitely learned a lot doing this as well. So if you enjoyed the video, give it a like, subscribe, and comment down below. I believe next up we have like a medical thing. Actually, we can take this, paste it in here quick, complete it. Yeah, next up we have this medical data visualizer, which I haven't done yet, but it looks pretty dang difficult. So yeah, that one should be good to do a video on, and yeah, I will see you next time. Peace.